Okay, this is a video about proportions in work problems. So first we're going to do the proportions and then we're going to do the work problems. Okay, so a proportion is, if you have a similar, you can use a proportion to find unknown lengths of sides if you have two similar figures. So if these figures are, if somebody says these are similar, then you can solve for the unknown side using proportions. So similar means the same shape but a different size. So in other words, this triangle is the same shape as this triangle, but it's so many times bigger than this one. And so that means that this side is so many times bigger than this side, and this side is that same amount bigger than this side, and this other corresponding side is the same amount bigger than this side. So that's what similar means. So we can set up a proportion. Here's a good proportion we could set up. We could say for number one, we could say this side, x is to this side 3. We could say x is to 3 as this side 10 is to 5, as 10 is to 5. That is called a proportion, and that's a good one to set up. Or we could do it this way. We could say 3, small triangle, is to 5, the corresponding side of big triangle. 3 is to 5, 3 is to 5, as x is to 10, as small is to big, as x is to 10. Or we could do something like this. We could say big is to small, 10 is to x, as big is to small, 5 is to 3. 5 is to 3. So all of these are correct. Any one of those would suffice to solve this, solve for x. These are all good proportions. So there's a lot of good choices you can make. There are a couple of bad choices you can make. There's something you could set up and think it was a proportion, but it's not. Let me show you one of those. So this is not a proportion. So I could say something like this. I could say 3 is to x, this side is to this side, and then I could switch it up, as 10 is to 5. If I decided to say this side is to x, as 10 is to 5, then I'm not putting the corresponding sides together. So this would be no good. That makes no sense. That's a bad one. So don't do that, but all of these are good. So let's pick one of these and solve. When you have a proportion, a fraction equals to a fraction, you can cross multiply. So I'm just going to do that here. I'm going to say 5 times x is 3 times 10 equals 3 times 10. 5x is 30, divide both sides by 5, and we get that x is equal to 6 for number 1. All right, let's look at number 2. These are similar figures. So if these are similar figures, then this is so many times bigger than this side. So I'm going to set up a proportion. Again, there's several you could set up. Let's just do this one. Let's say 4 is to x, small is to big, as small is to big, as 6 is to 18. As 6 is to 18. And so I'm going to cross multiply here and say 4 times 18 is equal to 6 times x. And I'm going to solve for x by dividing both sides by 6. All right, so x is equal to this. I'm going to simplify right here. 6 can go into 18 3 times. So 4 times 3 is 12 over 1. X is 12. All right, so that's proportions. All right, I didn't write all this down because it's on your worksheet. These are examples of work problems. Work problems can be come in about many different subjects, but they're common in that there's a job to be accomplished. So whenever there's a job to be accomplished, this is called a work, W-O-R-K, problem. So when we read number 2, and so I'll read it. It's on your worksheet, but let me read it in case for some reason you don't have the worksheet. It says, Jolene takes 2.75 hours to grade her algebra test. Debbie takes 3.5 hours to grade the same set of tests. How long will it take them if they work together? So the job to be accomplished here is grading a set of tests. Okay, so Jolene has a work rate, and then the other person, Debbie, has a work rate, and it says it takes Jolene 2.75 hours to grade a set of tests, and it takes Deb 3.5 hours to grade a set of tests. So it says if they work together, what is it? So each one of these has a work rate. This is how you would set up the work rate. You're going to let X represent the number of hours worked. All right, so Jolene's work rate would be represented like this. It would be X over 2.75. So that if Jolene worked 1 hour, 1 out of 2.75 hours of work had been accomplished. If she worked 2 hours, 2 out of 2.75 of the job is done. And if she works 2.75 hours, then 2.75 over 2.75 represents 1 job completed. All right, right here, this is Deb's work rate, X over 3.5. In other words, if Deb works 1 hour, 1 out of 3.5 is completed. If she worked, when X is 3.5, 3.5 out of 3.5 is 1 job completed. So that's how her work rate is completed. This plus is like they're working together. So how long does it take for them to complete 1 job? Now, if they had 2 sets of tests to complete, this 1 would turn into 2. There would be 2 jobs to complete. So how I'm going to solve this equation is multiply both sides by the lowest common denominator, and in this case, it's going to be 2.75 times 3.5, which I don't know what that is. Eventually, I'll have to get my calculator out. All right, so let's just do this. You multiply both sides by the lowest common denominator, and this will, of course, distribute. 2.75 goes into 2.751 times, so I get 3.5 times X plus 3.5 will cancel out, plus 2.75 times X is equal to 2.75 times 3.5. Okay, I can add those numbers together, and I will get 6.75 times X is equal to 9.625. And to solve for X, I'm going to divide both sides by 6.75. And I'll get that X is equal to 1.54. It takes 1.54 hours if they are working together. So a little over an hour and a half if they're working together. Okay, so the next work problem is number 4. It goes like this. It says that Mr. Crocker can paint his house by himself in 3 days. So it takes Mr. Crocker 3 days to paint a house. His son will need an extra day to complete the job if he works alone. So his son, if he's working by himself, it takes him 4 days to complete the job. Here's how we could represent Mr. Crocker's work rate, X over 3. This is Mr. Crocker's work rate. After he works 1 day, 1/3 of the job is done. 2 days, 2/3 of the job is done. 3 days, 3 over 3, 1 whole job is done. So in this case, X represents the number of days worked. That is what it represents, the number of days worked. So then it says if they work together. So if Mr. Crocker and his son, this is his son's work rate, the son's work rate. If they work together, how long till they complete 1 job? So we solved this equation for X, and it will tell us. Okay, so I'm going to erase this so I can talk about it. This is a rational equation. I'm going to multiply both sides by the lowest common denominator, and what that does is it eliminates the fraction, which is handy. So let's see. The lowest common denominator here is 12. If I multiply the left side of this equation by 12 and the right side of this equation by 12, that will work. This 12 will distribute to this term as well as to this term. Okay, so X over 3 times 12 over 1. 3 will go into 12 4 times. 4 times X is 4X. 4 goes into 12 3 times. 3X over 1 is 3X. 1 times 12 is 12. I get 7x is equal to 12. Divide by 7, I'll get x is equal to 12 over 7, or 1 5/7 of a day. That's how long it will take them if they work together. So those are a couple of examples of work problems.